If you've got your scientific calculator, it can do that for you. But if not, then you have to work it out a little bit. So what you're going to do is you know that the top number factorial is the 10. On the bottom, I have 8 factorial and 10 minus 8 factorial, which 10 minus 8 we know is 2. Hint, these numbers that are in your denominator factorial should be your exponents that you had on your probabilities here. So on the top, that's 10 times 9, because the 8, 7, 6, 5, 4, 3, 2, 1 cancels out with that. And on the bottom, I just have 2 times 1. So 2 goes into 10 5 times. 5 times 9 is, so I have 45 times 0.75 to the 8th power times 0.25 to the 2nd power. So you just type all those lovely little numbers in your calculator and get your answer.
Miss, is it 0.282?
Whoa, wait a minute. Hang on. I hit times 0.25. There we go. And what'd you say?
0.282. Well, that's what I rounded it to.
Yes, very good. 282.282. All right. So this is what we were finishing up from yesterday, correct? Okay. We had our formula for a binomial distribution. Okay. We used that formula to find certain probabilities if it's a binomial experiment. Now remember, the first part of the work yesterday, we talked about figuring out whether or not it was a binomial experiment. How many characteristics did it have to meet to be a binomial experiment?
4.
4. Okay, they were on page 540. Okay, on page 540, you had the 4 binomial experiment probabilities, or properties, not probabilities. Properties. So, okay, for quiz over this stuff, okay, the first 5 questions, that's what it's doing. You read the situation and say it's binomial or not binomial. Okay, so it gives you the situation. It's just like what we did at the beginning of the assignment yesterday. You read through the situation and you tell whether it's binomial or not binomial. So to be binomial, remember, it has to have only 2 outcomes for the experiment or the trial. Okay, binomial means 2. Okay, it has only 2 outcomes. Each trial has to be independent. That means if you pull something out and keep it out, is that independent? No, that's dependent. That changes what you can get next time. There is a fixed number of trials, so they can't say best 3 out of 5 or best out of 5 or best out of 10. You can't say that. It has to say they're doing it 20 times or they're doing the trial 15 times. And the probability of success has to be the same for every trial. There's a set like percentage of accuracy. So if I read this one to you, tell me whether it's binomial or not binomial. It says 2 soccer teams play each other 4 times during the season. Team A wins the matchup 82% of the time. Allowing for tie games, what is the probability that Team B will not win? Team B will win 2 of the games this season. So is that going to be binomial?
No. Yeah, no, actually.
The reason that
Not
it's
4.
is because it allows for tie games. Okay, if so, are there just 2 outcomes?
No.
You can have Team A win, Team B win, or a tie. So there's 3 different possible outcomes. To be binomial, it can only have 2 outcomes. Either Team A wins or Team B wins. Okay, but since it actually allows them to have ties, it can't be binomial. Okay, so that's the kind of thing that you're going to have on there. Listen to this one. A certain computer keyboard contains a total of 66 keys. A key is selected at random 25 times. Assuming each key is unique from the other keys, what is the probability that a letter will be selected 15 of the times? So the key can be picked or the key cannot be picked. So is that two options?
Yes.
Yes. Okay. Is there a set number of times they're doing the experiment?
Yes.
Yes.
Okay. So is that pretty much binomial then?
Yes, ma'am.
Yep.
Okay. So like I said, the first 5 on the quiz. Okay. And the quiz will be there today through tomorrow. Okay. The first 5 on the quiz, that's all you do. You read the situation, it's got the little drop down box, you put either binomial or not binomial. Okay. The next 2 are multiple choice. The next 2 are multiple choice. It gives you the situation, and then it says, what would the value of P be in the formula? So you're not having to work it out. It's just you to, after you read the situation, understand what the probability of the success is, what that number would be. So for example, if I say a toy maker produces a remote control car, however, 1 out of every 50 cars produced does not work. If a parent chooses 5 of these toys, what is the probability that one of them will not work? So what's the chances that it won't work? 1 out of how many?
50.
1 out of 50. So my probability value would be 1 out of 50, and then you can change it to a decimal if you need to, but that would be your p-value. Okay, so that means the Q would be, if 1 out of 50 doesn't work, then 49 out of 50 would work. Okay, if I wanted to know the N, the number of trials, or the number of success, how many are they picking?
5.
Okay, they're picking 5, so that's your number of trials. And X is what?
1.
Okay, so 2 of the questions are multiple choice. It gives you the situation and it says, okay, what would the X value be in the formula? And you just pick which one has the right number for X. What would the P value be in the formula? You just pick the right one from the situation. Okay, so those you don't have to work out, you just got to know which one's the right number. Then the last 2 are like these where you actually have to plug them in and work it out. Okay?
All right.
Got these that we've done the past today and in the class yesterday as examples. You should be able to figure out enough to plug it in, especially if you have a calculator, that you can do these quizzes, and hopefully these quizzes will be good. And then if you are struggling with it and have trouble with it, then you can ask tomorrow because it's open until after class tomorrow. Okay? You good with that?
Yeah.
All right. So what we're going to be working on today now is the review a little bit because we are done with chapter 11. Yay.
Yay.
Yay. So you'll notice the next few pages are review of chapter 11. Chapter 11 review. Okay, so it starts on page 548, so that's where we're going to start working. We're not doing all the problems. We'll go through some today, see how far we get. Then we'll finish up tomorrow. We'll talk more about if you have questions on the quiz tomorrow, anything else you need for the review to get you ready so you can take your test next week. Okay? Yes? All right, so everybody got 13A and 14A down, right?
Yes, ma'am.
All right, because I'm rolling over, so I have Blackboard. All righty. So here we go for the review, page 548. Okay, page 548. we'll start with 1 through 9, and then we'll go from there and start skipping around some. Okay?
All right.
So on the review, for number 1 and number 2, it says determine the number of successful outcomes. So all we do is we read the situation and then figure out what the successes would be. It says Carlos has eaten at least 2 pieces of candy 28 out of the past 31 days. My kind of person. What is the probability that he will not eat at least 2 pieces of candy on a given day? So if he does eat it 28 out of 31, how many days does he not eat 2 pieces?
3.
3. So he would not eat 2 pieces of candy. And that's it. That's all you have to do. Okay?
Okay.
Very easy.
Yes, ma'am.
Now, number 2. Alexis has written a poem 40 out of the past 52 days. What is the probability that she will write a poem on a given day? Well, how many days has she written a poem so far?
40 out of the last 52.
So,
52 days.
days that she wrote a poem. So there's 40 chances out of 52. You're looking for the successful outcomes, what they're looking for. Okay. Now for number 3 and number 4, it talked about valid and not valid. Does anybody remember the characteristics for probability to be valid? It had 2 things that it had to meet.
I think it was all the values are less than 1, and then all the values have to add up to equal 1.
All the values have to add to equal 1, yes. And all the values have to be between 0 and 1.
Yeah, between 0 and 1.
Okay. So looking at number 3, are they all positive?
Yes.
Yes.
So all between 0 and 1, because they're all a decimal that starts 0 point something. So then we add them up. If you add up 0.5, 0.2, 0.3, and 0.1, what's that add to equal?
1.1.
1.1. So does that equal 1?
No.
So it's greater than 1, so it is
Not valid.
okay. Now for number 4, look at it. Are they all between 0 and 1?
No.
Not valid because a negative, right? There's a negative in there,
Yes.
so it's not valid because of the negative. So those are your things for that. Pretty easy.
Yeah.
Yes.
Sorry, I'm just getting the death stare from my son. All right, number 5 and number 6. That'll be okay. It says find the relative frequency, round each answer to 3 decimal places. So this is where we're actually doing the probability. When it says relative frequency, it's the probability. So you're writing the fractions, the chances of what you're looking for, the successes, over the total chances, the total outcomes. So for number 5, it says Jennifer exercises most days, not me. In the past 30 days, she worked out 28 days. Okay. What is the probability that she will work out on a given day? So for number 5, probability that she'll work out is how many days does she work out?
30.
28.
Oh, yeah, 28.
Out of the past 30.
30 days.
28 out of 30. Now you can reduce the fraction to lowest term. So she worked out 14 out of the last 15 days. But normally they want the relative frequency written as a decimal. So you take 14 divided by 15. And you get
0.93333333333.
down to the nearest thousand. So you have 3 decimal places behind the decimal point. Okay. Number 6. What about Amber now? Amber has studied for her classes for 30 minutes, 5 out of the past 14 days. What is the probability that she will study for 30 minutes on the given day? So the probability that she studies, how many days did she study?
14.
No, she studied
Oh, 5.
5 days out of the class.
Oh, yeah.
So in
14.
14 days.
she studied 5 days for 30 minutes. Okay, so you have 5 out of 14, and then you get it as your decimal. You got to make sure you're careful with your rounding. It's a repeating decimal. That's not what I was trying to write.
Oh, 357.
Yeah, that's what I got.
I was thinking that the 7 didn't change, and so I wrote 7 instead of the 5. All right, so it's 0.357. So this part was pretty easy, right? We're good with this? Yes or no?
Yeah.
Let's put them down. Some of you missed some days in here throughout this, so hopefully this is giving you some examples to review. All right. Now for 7 and 8, on 7 and 8, it's talking about the complement. The complement is the opposite of it happening. So it's kind of similar to what we talked about over here. You know, if we had 8 successes, then that meant there were 2 failures. He made the shot 8 times, so he missed it twice. Okay, so this is, okay, she studied 5 days, so that means she didn't study 9 days out of the 14. Okay, that's your complement, opposite of what you're looking for. So on number 7, it says a certain newspaper has had at least 15 automobile advertisements, 35 out of the past 48 days. What is the probability that this newspaper will have at least 15 automobile advertisements? And then what is the complement? So the probability that it'll have an auto ad was how many days? 35 out of
48.
48.
So we take 35 divided by 48. About
729.
Okay, that's the chances that they will have 15 or more ads. So when I ask for the complement is no auto ad, the opposite. Okay, they're not going to have the 15 auto ads. So to find the complement, remember, the complement means you just take 1 minus the one that you had. Because remember, the 2 things together have to add to equal 1, because that means it's valid. So I have 1 minus 729. So the complement is 0.271. Okay. Remember that a little bit?
Yeah.
Number 8. Says Sarah took her umbrella to work 32 of the past 73 days. What is the probability that she will bring her umbrella to work? So the probability of her taking her umbrella is 32
32.
out of 73. So then we find that little decimal. Make sure it types it in right so y'all are getting.
0.438.
Okay. So then the complement is that she doesn't take her umbrella, right?
Mm-hmm.
Yeah.
It's no umbrella. So you take 1 minus 0.438 and you get
0.562.
So everybody good with that part?
Yes, ma'am.
All right.
Yeah.
Number 9, we'll just keep going down this side. Number 9 says find each compound probability. State whether the events are mutually exclusive or not mutually exclusive. Round each answer to 3 decimal places if necessary. So mutually exclusive, remember, means that one is completely separate from the other. So the chances of picking a red marker over the chances of picking a green marker. 2 totally separate things. It's not going to be red and green at the same time. So they're mutually exclusive. Now, the chances of picking one that has white and green on it, okay? If I say the chances of picking a white one or a green one, but what if this? It's got both. So I'd have to subtract it back off because it's not mutually exclusive. It's in both categories. So that's what we're doing on number 9. It says, Kavi is shopping for a vehicle at a dealership. The dealership has 324 cars, 89 trucks, 5 motorcycles, and 58 SUVs. So what's the very first thing we need to do? See how many vehicles there are total, right?
Yeah.
So how many vehicles there are total to choose from? Nobody knows.
Add them all up.
Them all up. So I take the number of cars, the number of trucks, the number of motorcycles, and the SUVs, add it all together, and there are,
476 cars.
okay, so that's total vehicles, okay? That's how many he has total. That's not cars, that's not trucks, that's not SUVs, that's all of them. All right, now for part A, it wants to know the probability of hitting a car or a truck, okay? So, can it be both a car and a truck at the same time?
Yeah.
They don't make those things anymore. We had, but anyway, so they can't be a car and a truck at the same time. So, how many cars were there?
324.
324.
Out of 476. And then how many trucks were there?
89.
89.
Out of 476. Add those two together. When they're mutually exclusive, okay, mutually exclusive, you just add the 2 things together. So 324 plus 89.
413.
And then we're going to divide that to get it as a decimal. Whoops.
0.868.
0.868 because you have to round up. Okay, so that's your probability of getting a car or a truck. Okay. Part B. Part B says a truck or SUV will not be chosen. So they're not picking a truck and they're not picking an SUV. Do you have stuff that's both not a truck and not an SUV?
Yeah.
There's going to be overlap. So these are not mutually exclusive. So when it's not mutually exclusive, that means instead of just adding, we're also going to have something we're going to have to subtract back off. So what we do first is we're going to have probability of, what was it, not a truck?
Yeah.
Not a truck. Wait a minute, a truck or SUV? Wait a minute.
Wouldn't you just add all the other ones that are not a truck and SUV?
Yeah, I was looking at the wrong, sorry. I was trying to mix part of this down with problem number 2. We're not even doing number 10, so. Rewind. Okay, so the probability a truck or SUV will not be chosen. So that means not truck or SUV. So, how many are not a truck or an SUV?
329.
329, he says. Y'all agree with him?
Yes, ma'am.
Okay.
You're back.
Huh? Yeah. Is that right?
Yeah.
What do you get when you do that?
.69 or .691.
So that one is still mutually exclusive. I was trying to read part of the things in question 10 a minute ago, and that's why I was almost up. All right, now this has a part C, doesn't it?
Yeah.
All right, so part C says a motorcycle, SUV, or car will be chosen. So you have motorcycle, car, SUV. So you add all those together, right? How many motorcycles? 5, right? 5 motorcycles.
Oh yeah.
I had those in the wrong order. It doesn't matter. How many cars and how many SUVs?
58.
58.
And the cars, 3, 3, 4. I had those in the wrong order, but that's all right. So you have all that added together divided by 476.
That's .813.
And again, that is mutually
Exclusive.
exclusive. Okay, so that was number 9. Okay. Now we'll do number 11. Okay. Number 11 says Emily has to pick a number between 1 and 10. Okay, so how many choices does she have?
10.
10, because there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10 choices. And so for part A, it says the probability of getting a 3 or an odd number. Okay. So how many 3s are there?
1.
1.
1. So you got 1 out of 10 chance of getting a 3. How many odd numbers are there?
5.
5, because 1, 3, 5, 7, and 9 are your odd numbers between 1 and 10. So she has 5 odd numbers. Now, is one of those odd numbers also 3?
Yes.
Yes.
So this is one where we have to subtract back off because it can be both of these at the same time. So it is not mutually exclusive because it can be both of them at the same time. So if you look closely at this, 1/10 plus 5/10 minus 1/10 is going to leave you with
10.
5/10, which is just going to be
0.5.
Part B. A 2 or a prime number. How many 2s are in there?
1.
1. Prime numbers. Prime numbers, remember, are numbers that only have 2 factors, the number itself and 1. So our list of primes, is 1 a prime number?
No.
2's prime, 3's prime, is 4 prime?
No.
No.
5's prime, is 6 prime?
No.
7?
Yeah.
8?
No.
No.
9?
No.
10?
No.
So these are prime numbers. So there's 4 prime numbers, but is one of these also the 2?
Yes.
Yes.
Subtract the 1 because it's not mutually exclusive. So when I do, I have 4/10, which is going to be
Point four.
And then part C says a 1 or a perfect square. Okay. So my chances of a 1 are 1 out of 10. Perfect square. Perfect squares means you took something times itself to get that number. So our perfect squares between 1 and 10 are 1, because 1 times 1 is 1. 2 times 2 is 4. So there's another one. And 3 times 3 is 9. There's another one. So we have 3 perfect squares between 1 and 10. But 1 was also one of those perfect squares, so I have to subtract it off. So I get 0.3 chances. Okay, because those were not mutually exclusive. Okay? Everybody good with that? Yeah?
Yes, ma'am.
Man,
All right. Now, let's see. Told you we were skipping around. Let me see what we were doing next. Okay, let's do 15, and then that'll be where we stop today. So, okay, so for 15, it says Raj has a collection of coins. He has 12 pennies, 14 nickels, 25 dimes, and 16 quarters. So how many coins does he have total? You have to add them all together.
67.
Okay, everybody agree with him? I haven't,
Yes.
I don't know. 20, 30, 50. Yep. All right, I hadn't added them up, so I didn't know. All right, so there's 67 coins total. There it is. Okay, so number 15, it says the probability that a penny will be chosen and a dime in order without replacement. So the chances of getting penny and a dime, but there's no replacement. So if I don't put the coin back in, do I have as many to choose from the next time?
No.
No. So what I'm going to have is this is called a dependent, because what I choose this time has an effect on the next time because I don't have as many coins to choose from. So for pennies, he had 12. So I had 12 chances out of 67 on the first one. And then for the dimes, there were 25 dimes. But since I kept the first one out, there's only
66.
6 to choose from that time. Now, when you are doing this, when it says and, you're getting 2 things out, do you add the fractions or multiply the fractions?
Add.
Add.
Multiply. When it said or, like we did on number 9 and 11, when it said or, we added. When it says and, that means they're both happening. You're keeping out 2 things, you multiply. So you work that out. You can try to cross cancel first if you want to, or you can just multiply straight across and then divide it, however you want to do it. So just work it out. That's what I got when I multiplied the fractions. And then when I change it to a decimal, I get big, long repeating decimal. We round off. So it will be 0.068. Okay. Now part B says a quarter and then a nickel are chosen without replacement. So again, that's dependent. Now okay, so all of these are going to be dependent on number 15. Everybody get that? Yeah?
Yes, ma'am.
Okay. So probability of a quarter and then a nickel. How many quarters did he have?
16.
So I got 16 out of 67. And then how many nickels?
14.
How many?
14.
14? Okay. You said 5, I thought you said 40. It was like, there was no, that would be. All right. So this is what we have that we're multiplying on this one. Remember, you had to count down because you kept the coin out. So 1667 times, I hit the wrong button again. I'm doing good at that today. You get a fraction. And then you change it to a decimal. You get big long decimal. So 0.05.
1.
Because the 6 makes the 0 go up. Okay? Good?
Yes. Yes, ma'am.
Let's do C. C says a dime and then 2 quarters without replacement. So I have dime, quarter, and quarter. Okay, again, all of these in number 15 are dependent because they're without replacement. We're not putting them back in. So my chances of getting a dime, he had 25 dimes out of the 67 coins. My chances of getting a quarter, he had 16 quarters out of the 66 that were left in his collection. Okay, then the chances of him getting another quarter. So you got to be careful. He already pulled out 1 quarter, so how many quarters are left?
15.
15, and how many coins are left?
65.
65. So you have 3 fractions you multiply together on that one. Whoa. What y'all getting?
I got 0.021.
Yeah.
Good. 0.021, because it's 0.0208, so the 8 is going to make the 0 go up. Okay?
Mm-hmm.
So we good with that?
Yes, ma'am.
All of those were dependent because they were keeping the coin out. Okay? Now, what I want you to do is don't forget to try to go and do that quiz. Okay? What else I want you to do is do number 13. On that review page we were just doing, I want you to do number 13. Now, the thing is on number 13, on these, it says with replacement. So since it's putting it back in, are they dependent? No, they are independent. So you do the same concept that we were doing on 15. You're going to be multiplying because it says and, but the bottom number stays the same because you put it back in before you draw the next one. Okay, so I want everybody to make sure they try to do 13 and have those answers ready for me tomorrow. And then don't forget about quiz. It's quiz G. Because like I said, section 11.6 was kind of considered optional, but we had time. I figured we need to do it. So, okay. So quiz G. And then number 13. And then I'll see everybody tomorrow at what time?
1 o'clock.
1 o'clock.
1 o'clock.
Bye.
Bye.
Oops, where's my button? Do you have a question?